Okay, good morning, everyone. How are we doing?
Good.
Yeah. Is it the day before your weekend retreat? Are you excited?
Yeah.
You know, it's so funny. It's like the day before a weekend retreat for us is like we're really happy, but now everyone watching this will be just as happy, even though it's a random Tuesday in 2028.
2028.
That's when they're going to be watching it. You know. Today we're going to be doing rational expressions. We're going to be adding and subtracting them. You see a bunch of examples. We're going to jump into those. So without further delay, yay math!
Yay math!
Yay math!
Yay math!
Earthquake effect. I'm going to lose my voice. Okay. So let's jump right into it. Rational expressions. We're talking about fractions. And what's the major rule when you need to add or subtract fractions?
Same denominator.
Common denominator. You okay? You're doing the shaking laugh thing right now. Those are always the funniest, because like from here, you don't know what I'm doing. But then I turn around and really just laughing. I'm not cold or scared. Okay, so what would be the common denominator here? What do we multiply top and bottom here by? 5. Good, we're going to just race through a few of these for the intro.
5. Oh, no.
Top and bottom here, multiply. 3. And what do we get? 13. Yeah, we get 13 totally, so I'm going to put this down. Plus 3 out of 15 makes total? 13 over 15. Okay, moving on. What would the common denominator here be?
DC.
Right. CD, DC, doesn't matter. So conventionally speaking, we say them in order of the alphabet. So you could say CD or DC, whatever. So if the common denominator is CD, what do we multiply top and bottom here?
D.
What do we multiply top and bottom here? C. I'm going to put it like over here. Why not? Why do we multiply top and bottom, real quick?
Because what you did to one half, you have to do the other
In a
half.
sense, yeah. What you do to the numerator, you have to do to the denominator. That's true. But can someone tell me what D over D is?
1.
So we're multiplying by 1. When you multiply by 1, does that change the number?
No.
Is A over C times 1 the same thing as A over C?
Yes.
And that's important. We don't want to change any of the fractions, otherwise we change the answer. Okay? Real quick, what would the instructions for this type of problem say? Would it say solve?
No.
No. What type of problem would say solve?
Something equals something.
Equal sign. X equals. A equals. So what would the instructions here say?
Add.
Simplify, right, simplify. So that's what we're going to be talking about. So simplify, here we go. This would be AD over CD. And this would be BC, right, or CB. And can I write them all over one fraction?
Yeah.
So basically that. Okay, so let's box it up. Box it up. And moving on, the plot thickens.
Did you say moving on?
No, moving on. Moving lawn. Or that's more like moving lawn. I pushed it back in the day, you know? Like the real, yeah, the ones that your ears ring and like you have to like bing, bing, bing. And then if you put your foot under it, you had a problem.
Oh no.
But I never did, so I'm good. So we're now going to talk about least common multiple. Someone define least common multiple in their own words? Take a hand. No one? It's okay. Yeah, try.
The lowest number that multiplies the following.
Yeah, you're basically there. The lowest number that all three of these can multiply to make. Evenly, yes, evenly. So for example, someone in the other class said 5. 5 is not a multiple.
That's a G.
5 is a factor. That's right. 5 is a factor. So we're not talking about factors. Indeed, 5 is a factor. But we're talking about multiples. So let's think of the number that all three of these can multiply to make. Any idea for a system, how best to do it? Yes, please, in the back.
If you take the biggest number and multiply it by
Yeah, the biggest number.
2.
Because you cover the most ground.
Yeah.
So we start with the biggest number. 120. Can 15 multiply to make 120?
Yeah.
Yes, it can. Can 70
No.
multiply to no? So, and 120 can multiply to make 120. So let's go to the next one, 240. Can 70 multiply to make 240?
Yes.
No.
7 into 24.
No, sorry, no.
That's 21. You need
Yeah.
21. 360.
No.
Yeah.
No, still. What's plus 120?
480.
40.
480, very good. Still?
Yes.
No? Plus 120?
No.
Think of 7 into 48, it wouldn't work.
Yeah.
So 600?
No.
No.
No? So none of these? 600? What's the next one?
720.
720, is that okay?
No.
770 doesn't go into that.
40.
840?
Yes.
Yes, yes.
Woo!
And you can check with calculator. 15 goes in and 70 goes in. In other words, the way I like to do this, if these were denominators and we were adding, this would be the common denominator. Okay? This would be the common denominator. So now we're over here. If these were all denominators, what would the LCM be? LCM be?
You do 27 times 2.
You're thinking 27 times 2? So we're going to work with 27, you're saying?
Because it's the biggest.
Yeah, it's the biggest. That's a good idea. So that's 54. Does
No,
12 go into
No.
54? No. Okay, so let's make a little note to ourselves. 54, no. Next group of 27.
18 goes in.
Yes, 18's cool.
So then, so can't you just keep multiplying it by 2?
By 2?
81.
Well, I think keep adding 27 will cover more ground.
81 doesn't
And you won't,
Then you know that 18
pass
is
over.
going away too.
say again?
If you keep multiplying 54 by 2, then you know 18 is going to go.
Sure, yeah, you will. You will.
I
And that's
found
actually
it.
the answer.
Oh.
Yeah, so we heard
It's not
81
eight.
isn't?
It's the
It's 108.
It's 108.
Oh, the next one.
So indeed, yeah, you keep going by 27. In fact, you could even multiply, there's a 6. One of these by 6, I think it's like 18 by 6, because they share a common
Yeah.
Yeah, it
6.
is.
That's another one.
108.
So 108. So the denominator would be 108 something. Let's erase this. Now, variables, stand over here. What is the smallest thing that a squared, a, and a to the 5th can multiply to make?
Hey.
I heard it once. It's not a to the 6th.
A.
Exactly.
8 to the 5th.
A to the 5th is correct.
Wait.
A to the 5th.
Why?
Let's talk about it. Once you see it,
Because when you multiply exponents, they add.
yeah. Can a squared multiply to make a to the 5th?
Yeah.
Times what?
A to the third.
A to the 3rd. Can a multiply to make a to the 5th?
A to the fourth.
Times a to the 4th. Can a to the 5th multiply to make a to the 5th?
Oh.
By 1. Right. So this is the smallest thing that all 3 a terms can multiply to make. And thus it would be the common denominator. So now, can you tell me the trick? What would be the LCM for the b's?
Nothing.
To the fourth.
B to the 4th.
Nothing. There's not a B in the middle term.
Correct, but it still is part of
They're
the
still.
denominator.
Yeah.
Yeah, it would have, you would need b to the 4th to be in the
Oh, yeah,
denominator
yeah,
because
yeah.
you're honoring this one. So we put b to the 4th, but I understand what you see there. What's the trick, basically?
Whatever the biggest number.
Highest exponent, very good. C to the
Third.
3rd.
Cube.
LCM, 108, a to the 5th, b to the 4th, c to the 3rd. Moving on. Okay. Is that the erasing sound? Do it right now, do it. Sounds like a whistle, like one of those handheld ones.
Oh no.
You're not a fan?
They
What?
I think like a month ago, a bunch of the seniors had those whistles.
Oh, that is like,
All the
I
little,
would've-
what are those
so
called?
annoying.
Yeah.
What are they
They're
called?
called the annoying ones.
The annoying ones. TM.
It was,
The annoying
I thought it
ones.
was a bird the whole time.
By Hasbro.
Oh.
So, here we go. We need LCM or common denominator. What will it be in this case?
63.
63 A.
AB.
63 AB. Because 63 AB is the smallest thing that 9B can multiply to make, and 7 AB can multiply to make. Okay. So, what does 9B need in
7A.
addition? 7A, top and bottom, multiply. What does 7AB need, top and bottom? 9. And what will the left fraction result in?
56 A squared.
56A squared minus
9
Minus
over
9.
63.
63.
All over 63 AB. All right, skip the next one, going into
Wait,
this.
8A times 7A is
I'm glad you're asking, yeah. 8A times 7A, 8 times 7, 56, 8 times 8A squared. Okay, we're skipping the next one, getting into the meat and potatoes. Sweet potatoes, it's a superfood. Don't worry.
Skipping 2 of them?
Yeah.
Did I skip 2?
Yeah.
Yeah, it's worth it, because they're the same. They're the same as this. Minus 2 over x squared plus 4x plus 4.
Factor.
Yeah, factor's the way to go. Factor's the way to go.
Ew.
Still, but factoring,
No, I'm better.
factoring loves you. Factoring loves you.
That's reassuring.
Factor's still waiting for you to accept their friend request. Wouldn't that be funny? You wake up one day, it's like, factoring sent
You
your friend request.
would. You totally would.
Would you accept?
No.
You would not. You'd be like, ignore or just leave it alone.
Ignore.
You'd actually say no.
Yeah.
Wow.
Suspicious.
I never said I was
How
nice.
means factoring.
I know, that would be.
It would
It'd
be
like,
you.
this is the photo is like 2 people like this. Parentheses.
It would be you.
It'd be me. Not like me around the parentheses.
You're gonna go home tonight and you're gonna make that Facebook account and add all of us.
Everyone join, please. So let's see if you guys maybe have a secret friendship with factoring. Does this factor?
Yeah.
What do you got?
X plus 2, X plus 3.
Is that what you're gonna say? Cool. I saw it in your eyes. X over X plus 2, X plus 3. This one's a bit easier. Minus 2 over what?
X plus 2.
X plus 2. And I'll just write it twice so it's more clear. Oops. Wrote the book.
Oh.
Okay. What will be the common denominator?
X plus
X
2, X
two
plus 3.
plus-
X plus.
I'm gonna write that.
X plus 2 squared. No, X plus 2 squared.
Yes, it is X plus 2 squared. It is X plus 2 squared. Let's talk about why sometimes people gravitate to this, because it's tempting, because it looks alike.
But there's 2.
Can X plus 2 times X plus 3 multiply to make X plus 2 times X
Yeah.
plus 3? Yes.
Yeah.
So this denominator, common denominator, would work here. However, can X plus 2 multiply to make X plus 2 X plus 3? No. So what do we need?
Square.
Squared here. Yeah, we need another X plus 2. Now can the first term multiply to make this? What does this need?
X plus 2.
It needs another X plus 2.
So you have to take something from each side, basically.
You have to take enough pieces from each side so that all pieces are represented. Another thing I like to do, you guys, it works for me, you're welcome to try it, you're invited to. I try to write it with some space between so that I could slide in these things here. So what does this need?
X plus 3.
X plus 3 in addition. Let's go with that. Something a little more poppy. There we go. X plus 3. X plus 3. And now we distribute. I'm going to write 2 steps. Distribute the top, please.
X squared.
X squared plus 2.
X squared plus 2.
X.
X
X.
minus permission to distribute the negative. Okay?
Permission granted.
Thank you. Minus what?
2x minus 6.
2x minus 6 all over x plus 2 squared x plus 3. Combine those of like terms.
X squared minus 6. Minus 6.
Question, please.
You have 3x plus 2, so why do you square it? What happens to the other one?
3x plus 2's? Here?
You have it on that side and you have it on that side.
Over here? No, there's 2. 2, bless you. That was nice. It was like not, and then it came. Yeah. So this x plus 2 belongs here. And I count 2x plus 2's and an x plus 3. And over here we have 2x plus 2's and an x plus 3. They look very similar. Is that okay?
Yeah.
Okay. All right. And so we have this. Be prepared onto a quiz or a test or something like that. This may be factorable in the future. Is it factorable now?
No.
What would this 6 need to be?
9.
Maybe a 4. If it were a 4 or a 9. Or a 9, very good. You get the x plus 3. If it were a 4 or a 9, then some of those factors will cancel with some of these.
Ew.
I I believe you. You would not accept the friend
So
request.
gross.
I believe you. But that's not cool, like the whole cancellation, like, oh,
Yeah.
yeah, another chance.
No, like that's
Yeah,
cool, but
mine
like
is
if
one
I
on
ever
the
got
test.
it.
If I ever got it, right?
Okay, whatever.
Yeah, you get it, you get it.
I got it.
At least now we're aware.
Yeah.
That's a very elevated statement if you think about it.
Go Gabe.
Just being aware. Being aware. Okay, so where are we? X minus 5 over 2x minus 6 minus, leave a space, minus x minus 7 over 4x minus 12. Okay? What do you suggest we do first?
I got the
Fact.
greatest common denominator.
Yeah, we're gonna find the factors first so that we can do that. So x minus 5. What's GCF down here? 2 times
X minus
x
3.
minus 3 minus GCF over here.
4 X minus
4 x minus 3. Okay, this is sometimes challenging for people. Show me with your fingers what you would need to multiply top and bottom on one of these. What number? Yes. Yeah. Wow. And we're like, what's up? 70s. I wasn't in the 70s, don't worry. But if you were at home, we love you. Yeah. Headband. That's like different in the 70s if you're doing that, you know. Might be not laughing, might be overdose. Anyway, never mind.
Okay. Too far.
I'm just honoring history. Okay, indeed. So we need to go here. Okay. So what does this become?
2x minus
2x
10.
minus
Yeah, 2x
X minus 10 over
over 4 times x minus 3. Now, can I combine the newmies?
Why did you
please.
multiply
Yeah.
by 2?
Don't say that.
Because this will now become 4 times x minus 3, which is our target.
And then X minus.
And I'm going to combine the newmies.
I have a question first.
Yes,
How much
please.
you apply the 2 to the x minus 3?
Oh, to this?
Yeah.
Okay, because of the rules of multiplication.
Do you make it
What is
square?
2 times 2 times x minus 3?
No, 0, 1.
Oh my god.
4.
Oh, 4.
Times
yeah.
x minus 3. Distribution
Yeah,
occurs with
okay.
plus or minus.
Okay.
Thank you for asking. Yes?
Couldn't you just multiply the one side by 2 and not take out the greatest common factor?
If you saw that, yes. At the original step, do you see that this lacks a 2
Yeah.
compared to this? If you saw that, sure. That's good. Good find.
You didn't get it.
Okay, if I were to combine the numerator, I won't say newmies anymore,
Thank you.
what would this become?
Minus x plus 7.
Minus x
What?
plus 7.
Why?
Because the minus switches.
Distribute the negative. This negative applies to the whole side.
So would it be X
So it'd be
minus
X.
2?
X minus
3.
3. Oh, sorry.
Over
Over 4.
X minus
And then make it 1
Oh,
over
wait,
4.
can we knock it out?
We can knock it out.
Knock it
Wait,
out.
why'd you add, why is it plus
So it's just
7?
4.
It's minus
Or 1
7.
over 4.
Why is it plus 7, Gandalf? Yes, you.
Me?
Yeah.
What was it? Sorry.
Why is it plus 7?
Because you distribute the negative.
Distribute the negative. This minus is sort of like this. Plus
Well, I like
negative 1. I change it to plus and minus 1.
I did.
What happened?
I don't know, I just like the
I do
tissues
tissues
here.
on
Tissues just appeared on your leg. Happens to me all the time. Yeah, so this negative actually distributes through. So it's sort of like minus 1 times this whole thing. Here, I changed it. This negative is like plus negative 1 through the whole thing. Just like this minus distributed to the whole thing. Remember this over here? Minus 2 times x minus 3 is really minus 2 minus 6. 2x minus 6. It goes all the way through. So same thing over here. And now we cancel them. So does it boggle your mind even a little that this whole thing is the number 1/4
Yeah, it
or
does.
0.25?
It's really
Would that be
annoying.
crazy? The other class had this idea that they would like do a math project at a supermarket. they'd say like, your total today is $8 and x over 5 over 2x minus 6 minus x minus 7 over 4x minus 12 cents. And then you'd be like, oh, 25 cents. Because there's no x anymore.
Got it.
That's
thanks.
cray fish.
Face.
Do you guys say cray?
Yeah. I say cray.
No.
Just like one.
I say, okay, so I say cray fish.
Rachel's
I
into
say-
like that, like half.
I say crate.
That's most deaf.
I say, give me another one.
That's fab.
Fab.
That's perf.
No,
Perfect.
no,
I don't say
stop it.
perfect.
Let's stop.
Gilly says perfect.
I think to the people that are watching this, they might just turn it off because of all these.
Cray,
To all those
Rate
watching,
barrel.
apologize
I will
in
walk out of
advance.
this room.
cray,
That'd be crazy.
crayon.
I will take this camera with me.
Yeah.
I'm leaving.
Yeah.
Like move.
I saw you going to the bathroom. I'll be right back.
Okay, have fun. That was very dramatic. I should take notes from that guy. Like, I'm out of here. Bathroom.
Still.
You're like, whoa! Oh, God, did you have to do it that way? Okay, this one's cray. Now we can have fun. Like, crayola, crayon, crate and barrel. Anyway, getting too into it. We need to make this one fraction upstairs. So upstairs, what is the common denominator? 3. So I'm going to write 3 here and 3 here. How's that work? Does that work okay? So what will I multiply top and bottom here? 6. You're doing it. And so top becomes 4x over 3 all over 5x over 6.
And then
Wait. Oh,
Pause.
minus. Yeah.
We're
Do
okay?
the multiplication or you switch?
Multiplication of reciprocal, you got it. So now that becomes
Nice.
4x over 3 times what?
6
6
over
over
5.
5x.
Wait, what are we doing here?
Here
And
we
then
want
you
to cross
can
multiply.
Cross,
Wait, question. I'm kind of.
please, yeah,
I don't
ask.
get this.
Oh, dividing. Oh yeah, you weren't here for this. Okay, let's jump into it. It's okay. But the rule is dividing by fractions is the same as multiplying this top fraction by the reciprocal.
Okay, so 6 over 5.
Yeah. Remember the rule? Dividing by fractions is multiplying by the reciprocal. Yeah, so that's the rule. So now I'm gonna cancel x. I'm so tempted to jump into it.
Whoa.
Dude, you left enough to the bathroom. You can't be like, go back.
Okay.
What cancels now? What else?
6 and 3.
6 and 3.
2.
1 and 2.
That's 2. What are we left with?
8 over 5.
8 over 5.
8 over 5.
Very good.
Yeah, you're gonna go over this with me when we're done.
We made common denominators here,
There's another one.
top and bottom. Right, so these are both, we made them into common denominators.
So you have to multiply the.
Yeah, I'll go over it with you. I'll go over.
Stay as victorious.
Last one.
3 and 6.
Okay.
Doesn't look like an L.
It's okay.
So the area of a rectangle is given as 4x plus 16. They like this stuff on maybe SAT 2 or things like that. Even SAT, you know, yeah. You already took it, congratulations.
Me too.
Next year. Another stab. If we're given the area and we're given the length, how do you think we find the width?
Divide.
Divide. I'm going to make the equation of the area of a rectangle. Please help me write it. A equals
B.
L.
L times W or base times height. Same thing. So we're going to say A
That's just kind of.
equals L times W.
Equals B
B.
squared.
I said
I
B
said
too.
B because of you.
And now we're going to fill in our formula. You guys have done really well. So we're reached the end of the line. We're going to fill in our formula. What would A be?
4x plus 16.
4x plus 16. What would L be?
X plus 4 over X plus 2.
X plus 4 over X plus 2. And we don't know W. And now the problem is asking for what?
W.
Solving for W. How do we isolate? We can multiply by x plus 2 and divide by x minus, or x plus 4. We can multiply by the reciprocal. We do
We
that.
can do x, yeah.
Or we could even jump into what we've been
Simplify.
doing now. If I divided this whole side by what?
4x. No.
No.
No, good guess. I'm trying to get this by itself.
W.
X plus 2.
X plus
One
4
over
over X
double.
plus 2.
By this thing, exactly. I'm going to divide by this whole
So you
thing.
flip it.
I will over here. You'll see. Yeah. So this is dividing by the whole thing. Just so you get a feel for it. I'm going to say a sort of a tongue twister, and I feel like I'm optimistic that you're going to get it. Is x plus 4 over x plus 2 divided by x plus 4 over x plus 2 equal to 1?
Yes.
Yes.
Yeah, that's the idea.
Why is that tongue twister?
Because there's a lot of x4s,
X plus 2,
x2s.
x plus 2, x plus 4.
Divided by, put it in red again, x plus 4 over x plus 2. And now we're basically looking at a problem similar to this. So we can go ahead and get rid of it here. Okay, so 4x plus 16 divided by x plus 4 over x plus 2 is the same as what?
Hold on.
Yes.
4x plus 16 over 1 times x plus 2 over x plus 4.
Yeah, we're gonna learn today.
Is this what you did on Monday? Also?
Yeah, this idea.
Okay, so.
Wait, isn't it 4x plus 16?
Good job. Yeah, that matters.
And then you take the 4 out.
And then
Good, factoring. 4 times. So, oh, someone likes factoring. Everyone, friend of friend. You may like factoring because she does. Plus 4 over 1. Factoring suggests you like common denominators. Sorry, too much fun. Too much fun.
X plus 4 is canceled.
Yeah. Confused.
Oh yeah, x plus 4 is canceled.
Cross it.
You're left
I
with
know. the
4x
answer.
plus
4x
2.
plus 2.
Plus
4. Yep.
parentheses.
Yep, so it's either one, it's either 4x plus 2 or 4x plus 8. Right when it runs out of ink, awesome.
Perfect
And
time.
that's
That's
what
what
W
W equals?
Oh, that's what W equals, yeah.
Should we write W equals or can we just?
Sure, you can be thorough. Yeah, if it's asking what is W, so if you want it to be thorough, you're good to do that.
Would it be wrong if we just write 4?
No, not necessarily. No. No. Any questions?
No.
You guys pretty much handled that, okay? So give yourselves a hand, please. All right, see you next time. Say bye. Bye.